Alright, so in this experiment, you place your coin on the note card, which is on top of the beaker, and then you flick the note card like so, and as you can see, the coin falls straight down because of Newton's laws.
2.
Alright, I have a stack of pennies here and 1 penny here. Watch what happens when I flick this penny into the stack.
Whoops.
Ooh, almost did it for me. Oh, I'm so bad at this. Alright, well, what should have happened is this penny should have hit this stack right here, and as it went in, it would have replaced the bottom penny, and the bottom penny would have shot out. It's hard to do, so why don't you guys try it at home and see if you can do it yourself.
Hello. Alright, for this station I am taking this plastic blue ring, setting it and bouncing it on this bottle cap. I'm taking this little golf tee, setting it on top, and theoretically I should be able to pull away the ring fast enough that it doesn't move the golf tee, and the inertia just makes it fall straight into the bottle. It's really hard to get, but almost got it.
Close.
I'll get it.
Oh.
Close.
You can try the other one. Yeah.
On this station, we're going to perform a magic trick. So I have the table set up for a nice date with my wife, a candlelit dinner. We drink out of beakers because we're science teachers. And I have glass plates and silverware. And what I want to do is I'm going to impress my wife by pulling out the tablecloth from underneath it. So ready? 3, 2, 1. So some tips on doing this. You can do this at home. What you want to do is make sure that you have a couple of different things. First off, there's a difference between the different masses that we have, so that's going to affect the inertia, and that's part of what we want you to look at in the station. Secondly, when you go to do it, you have to do a couple different things, such as make sure that there is not a seam on the edge of your fabric, or the seam will catch the object and bring it with you. Secondly, make sure that there aren't any gathers, like there's a gather here, because that gather would also catch it and pull it. So as you're doing it, you might have noticed me at the beginning trying to straighten this out and make sure it's as flat as I can get it. And then what I would probably do for you to start with is start with something really heavy, because you're going to have a better chance of being able to pull the cloth out. Lastly, when you go to pull the cloth out, make sure that you pull the cloth straight towards you. Don't pull it down, don't pull it up. It's got to come straight out, and do it as fast as you can. And that's the station, that's the magic trick.
Go.
So in this lab we have 2 eggs. One of the eggs is hard-boiled and one of them is not. If you have some eggs at home, try this. Make sure you hard-boil one. So what I'm going to do is spin them. I'm going to get them both spinning, and then I'm going to real quickly stop them. And notice how the one that is on your left stopped spinning, but the one that is on your right, it started spinning again. So let me do that one more time. I'm spinning. I'll spin this one, quickly stop it, and then notice that when I let go, it starts spinning up again. And on this one, I spin it, stop it, and it just stops. So what about the egg? How would you know if it's hard-boiled or not based on Newton's laws? How would you determine that?
Alright, so this is the popper station. This one's going to describe Newton's third law. And so in this station here, the table is going to exert a force here on the popper. So where is going to be the equal and opposite force in the popper?
So we will be pulling on the springs, and as I pull, there will be force on his, and then when he pulls, there will be force on mine. And as we pull, you can see
that they are roughly equal because the forces pulling on each are about the same.
Okay, so we're going to put our feet together and kick off, and we're both going to go in opposite directions. I went less far because I'm more massive.
And I went further because I weigh a lot less.
All right, so in this station here, I'm going to be pulling 2 books here at different forces with the spring scale.
And then we're going to time it, and we'll stick them on the chart for our sheet then. Okay, ready,
Yes.
set, go. Okay, and
That
what
was
force?
about 7 newtons.
So 7 newtons, and our time was 4.96 seconds. Okay, I'm going to reset, and we're going to do 2 books again, but a different force. So ready, set, go.
That was about 10 newtons.
10 newtons, and I have 1.81. And as you can see, this is not super accurate. We're just trying to get an idea off of this. So ready, set, go. Oops. Try it again. I
Okay.
didn't get the
That's fine.
stop on that one.
I didn't get a good reading on it either, so.
And that is what science is all about, trial and error. You tell me when to go.
Okay. 3, 2, 1, go.
Okay, what did you get for that?
That was about 12 newtons there.
Okay, so 12 newtons. So I have the 7, the 10, the 12, and I have my times here for each of those. And then what we're going to do is calculate the acceleration and see what happens as the force increased, what happened to the acceleration.
All right, so in this station here, we're going to be actually adding books here, but we're going to be pulling with a constant force while measuring the time.
You tell me when.
Okay, so 3, 2, 1, go.
Oh, start over. I didn't get the time, sorry.
That's okay. Okay, so
ready?
3, 2, 1, go.
Okay.
Okay, so that's about 10 newtons there.
So we had 10 newtons of force, and our time was 4.42. So we're going to try and pull 3 books now with the same amount of force, 10 newtons of force. Okay. Ready?
Yep.
Set.
Go.
Okay. So that was 5.26. Okay, now we have 4 books on there. Let me know when you're ready.
All right, so 3, 2, 1.
Again, we're trying to keep this still at 10 newtons of force. And that was 8.14 seconds. So we're going to take that same distance of 1 meter and the time that we have, knowing that our initial velocity was 0, and calculate the acceleration. And then we want to see, as we added more books, which was more mass, what happened to the acceleration.